Okay, welcome back to the GCSEMathsPro YouTube channel. So in today's live, we're just going to be walking through the June 2023 paper 1 higher, as you can see, Edexcel higher tier. This is non-calculator paper, so you don't need to use your calculator for this one, and obviously definitely try not to use the calculator so you can get used to seeing which bits you might actually not be so sure on without one of those. So I'm just going to be walking through it. If you've got any questions, please send them in the chat. Otherwise, I'm just going to keep going. So our first question, we've got work out 8.46 divided by 0.15 for 3 marks. So obviously this would be quite easy if you had a calculator, but I feel like we often forget how to do it, especially when we've been using a calculator for so many years. This is more of a Key Stage 3 method. So there's different ways to do it. The way that I would do it, because it's divide, is if we change both numbers by the same scale. So what I mean by that is, for example, do you see how both have 2 decimals? If I were to multiply both by 100, so times both of them by the exact same scale, times by 100, you get 846. And then you would get divided by 15. So they're both whole numbers now. I prefer to do that. The reason why I choose to keep them multiplied by the same number, so both by 100, I've changed the decimal place by 2 places, is because then whatever answer I get for this divide, I don't need to scale it back again. That is just the same answer. If you were to change one of them by 10 and one by 100, for example, then you would have to kind of figure out the scale at the end, where to put the decimal place if there is one. So I like to just multiply them both by the same. In this case, it worked out quite well that they both would multiply easily by 100. And then I would just personally use bus stop division. That's just my preference of doing this. So we've got, obviously we're dividing by 15, so that's on the outside. Draw a little bus stop, 846 on the inside. And then obviously 15 won't go into 8, so I just skip that one straight away and I look at the first 2 digits, 84. I think for higher tier it's quite handy to know some of the 15 times tables, because I feel like 15 comes up quite a lot, so it might be handy to kind of, maybe up to like 6 times 15, just learn those. So actually 15 only goes into 84 5 times, so we put 5 at the top here, and then we have a remainder of 9 because 5 times 15 is 75. So we'll put a little 9 here, that's now 96. How many times does 15 go into 96? Well, it goes into 96 times. So we put a 6 here. And then we still have a remainder, so that's where I'm going to put my decimal place. Obviously put zeros here. The remainder is 6. Obviously put another decimal place at the top as well. How many times does 15 go into 60? Well, we just said that, didn't we? It goes in 4 times exactly. So because it goes in exactly, there's no more remainder. That is just your answer, isn't it? 56.4. And as I said, because I changed both of the numbers by 100, I multiplied them both by the same scale, 56.4 is just the same answer. I don't need to try and figure out where to put the decimal place. That is just correct. So that is how I tackle the first one. On to our second one, we've got some fractions, mixed numbers. So work out 7 and 3/8 minus 2.5. Give your answer as a mixed number. So currently they are as mixed numbers, aren't they already? You have 2 options here. You can either subtract the 7 and the 2 as whole numbers and then deal with the fractions separately, or you can convert everything into improper fractions and just subtract everything. I'm going to do that just because then that method is consistent with adding, subtracting, multiplying, and dividing. But it is up to you. So to convert into an improper fraction, we take the whole number, multiply it by the denominator. So the first one will be 7 times 8, which is 56. And the 3 at the top is like a remainder, isn't it? So 56 plus 3 is 59. So that would be 59/8 as an improper fraction. Obviously then subtract. We've then got the same here. So 2 times 2 is 4 plus 1 is 5. So 5/2. Now, when we're subtracting fractions and when we're adding them, we need to have a common denominator. So 8 and 2, we need to find the lowest common multiple, which is 8, which is good because then it means I don't need to change the first fraction, just the second one. So my first one is still 59 over 8 for now. Minus, and then I want to change the second one to something else over 8. And obviously, if you change the denominator, you have to also change the numerator. So do you see how I went from 2 to 8? That is obviously multiplying by 4, isn't it? So I'm going to do the same with the numerator. 5 times 4 is 20. 20. Now if we subtract them, we're just subtracting the numerators, okay, just the top numbers. So 59 minus 20 should give me 39 over 8. Now the only thing though to remember is they did say to give it as a mixed number, so this isn't the correct format for the answer. So I need to convert it back into the whole number and then the leftover fraction. So that's where we say, right, how many 8s go into 39? Well, 4 would go into 32, wouldn't they? So we've got 4 as a whole number. And then what's the difference between 32 and 39? Well, that would just be 7, wouldn't it? So then the leftover is 7/8. 4 and 7/8. So that is how we'd answer question 2. Okay, moving on to question 3. We've got a cube has a total surface area of 150 centimeters squared. Work out the volume of the cube. So surface area and volume, we need to know kind of what the difference is between them. Surface area, you see centimeters squared, is still 2D. Now I know it's in a context of a 3D shape. A cube is a 3D shape, isn't it? But the surface area, if I draw a rough cube here, is just the area of all of these faces. Now you can see 3 there, there's obviously 3 on the other side that you can't see, added together, which is 2-dimensional. Volume is obviously then the capacity, like if we were to colour it in, if you were to fill it with water, that's the capacity, isn't it? Volume is 3D. So we're working backwards from surface area. Don't worry about the volume for now. How do I undo the surface area? How have they worked out the surface area? Well, because it's a cube, all of the sides are the same. So let's say that that side is x, then that one would also be x. And what they would have done is they would have done x multiplied by x to find this area here, wouldn't they? One of the faces. So that's x squared. Now the surface area of a cube, there's 6 of the same face. So that would be 6 lots of the x squared, wouldn't it? Do you see how that equals to 150? If I write it like this, then I've just got an equation that I can solve. So first of all, we'll divide by 6. So we get x squared. 150 divided by 6 gives you 25. And they've obviously chosen a number that we can now square root. So if we square root both sides, we obviously get x is 5 centimeters. So that is the side length of our cube. Now I can worry about the volume. How do I work out volume? Well, volume is normally all of the 3 sides multiplied together, like length times width times depth or height or whatever you want to call it. It's those 3 dimensions, isn't it? Which we now know all of them are 5, aren't they? If I change this. Do you see how this is 5, this is 5, this is 5? All of them are 5. So the volume is just 5 times 5 times 5, or in other words, 5 cubed, which is 125. And now that's obviously 3D. So there's your answer for part 3. Question 4. The table shows information about the daily rainfall in a town for 60 days. So we've got a frequency table here. We need to convert this into a frequency polygon. So frequency polygons, we are plotting, obviously you can see on the y-axis frequency, so that's just the second column there. But on the x-axis, what are we plotting? In this case, we're plotting a midpoint. So the midpoint between these ranges, okay? So you would need to go in and work out what is the midpoint of each of those first. So this one's obviously 2.5, 7.5, 12.5, 17.5, and finally 22.5. And then we're just going to plot crosses on each of those. So we go across by 2.5, check the scale. You can see that's obviously halfway between these two lines, the 0 and the 5, halfway. And then up to 8, which looks like 1 square per one number in the frequency table. So that's 8 squares up. It's about there. Then we've got 7.5 up to 24. Then we've got 12.5 up to 13. There. 17.5 up to 11. And finally 22.5 up to 4. Here. So then you're going to get your ruler and you're going to join up all of these individually. So let's get a straight line. Let's see if it will let me draw it. So like that, that's the first one. Then the second. The third, and then the last one. And that's it. That's a frequency polygon, okay? So it's kind of jaggedy like that. So that's all we need to do for question number 4. Question number 5, we have Venn diagrams. So we've been told this little kind of squiggly shape here that looks a bit like an E means the universal set. And what the universal set means, as you can see it's also copied here, it just represents everything that's in the Venn diagram, whether it's in the circles, whether it's just around the outside. It represents everything that's in this rectangle, basically. So they've said the universal set is effectively numbers 1 to 10. That's what they're saying. Then they've said more specifically, so from those numbers 1 to 10, the ones in the A circle are odd and the ones in the B circle are square numbers, and therefore the overlap would be those that are odd and square numbers. So we need to complete the Venn diagram for this information. Now I might try and see if I can zoom in a bit. There, just so that we can really look at it in more detail. Okay, so before I start, what I'm going to do is list down the A and the B set. So what I mean by that is odd numbers is obviously 1, 3, 5, 7, and 9 from the list above. And then the square numbers is 1, 4, and 9. So just list those so you can tick them off as you go. And then let's go through in order. So number 1, you can see that's in both A and B. So I'll put that in the middle. And then we cross it off so we don't forget anything. Then carry on. Number 2, that's not in either A or B, that's on the outside, isn't it? So put that there. Number 3 is just in A. Number 4 is in B. Number 5 is in A. Number 6 is in neither of them. 7 is in A. Again, 8 is in neither. 9 is in both. Cross all of that out. And 10 is in neither. So make sure, the reason why I checked them off is just to make sure that I haven't missed, obviously the ones in A and B are kind of fine, but it's just making sure I haven't missed any that should be on the outside. So that's our Venn diagram completed for 3 marks. Now if we scroll down, I think we have a part B. So a number is chosen at random from the universal set. So what they mean by that is out of the whole Venn diagram, they picked a number. So that means they picked one of the numbers from 1 to 10. Find the probability that this number is in the set. Now this bit here means not B. When you have an apostrophe, that means not B. So where is not B on our diagram? Let's highlight it. So it's just anywhere that's literally not the circle of B, basically. So if we were to highlight, try and do this. Let me get a smaller one. It's basically all of this, ignoring the circle B, isn't it? All of this, all of this. Okay, not B is everything that is not in B, literally. So then you're going to count, how many do I have? 1, 2, 3, 4, 5, 6, 7. It's a probability, so I'm going to put it as a fraction. 7, and then how many is in the whole universal set? Out of how many am I choosing from? Well, there were 10 numbers, weren't there? So do you see how that would be 1? That would be 7 out of 10. You could put 0.7 if you want, but I think fraction is a bit easier. It's literally just that. Identify the section that they're referring to and then put it out of, if they've said the universal set, then out of the whole set. Let me scroll down because I don't think we can see that answer there. There we go, 7/10 for not B. It's 2 marks because literally it's 1 mark for the numerator, 1 mark for the denominator. Okay, question 6. The scatter graph shows information about the ages and weights of some babies. So we've got obviously weight on the y-axis, age in months on the x. Describe the relationship between the age and the weight of the babies. So this is obviously a worded answer. They've put 3 lines, but you don't need to fill out those whole 3 lines, right? This is a really basic answer because ultimately this is maths. They're not looking for a whole explanation, are they? So let's see if it will let me type or if I'll just try and write it. There's obviously different ways of putting it, but it's pretty obvious that you can see, just describe what you can see on the scatter diagram. Can you see how obviously as the age increases, the weight also goes up? That's basically what they want you to say. So they have also accepted in the mark scheme positive correlation. You could literally just write that. That's kind of the easiest thing to say. But I think I would say, if you look at the x-axis, as age increases, comma, weight increases. It's meant to be something really obvious. Like, it's not meant to be really hard for you to kind of like analyze it because it's a worded question. It's meant to be super just basic, whatever you can see in front of you. So you can either write that, which is kind of, you know, obvious, or they have, as I said, accepted positive correlation, which could also be maybe an easier thing to write down for you. Whichever of those two, or some version of, you know, as the age increases, the weight increases, some version of that is fine. So part B, as another baby has a weight of 5.8 kilos, using the scatter graph, find an estimate for the age. So what I tend to do is when they ask you to use the scatter graph to find an estimate is we normally want to draw a line of best fit. So you're going to get your pencil and your ruler and draw a line of best fit. A line of best fit is where we're going to try and draw a line through, obviously here there's quite a strong correlation, through the points and try and have just as many points that are above your line as there are below. So it's kind of halfway through the points as best you can. You know, again, it is an estimate. Not everyone's answer will be exactly the same. So roughly, I might draw mine maybe like this. Something like that, just so that you can see you've roughly got a similar amount of points above the line as you have below. It's kind of going roughly halfway through. And then you can look at the number they've given you. So they've said the weight is 5.8 kilos. So obviously that's on our y-axis. So then we draw our line, we get a ruler and draw a line at 5.8. Do be careful of the scale though. Do you see how, I feel like you could quite easily go, yeah, it's just 2 squares before 6, but actually it's not. Because the scale here, that's 5, isn't it? So every 1 square represents 0.2. So actually 5.8 would be here. Can you see that? Just be really careful of the scale. I feel like that's how they make these questions harder. So then draw your line across. And then draw one down. So obviously we're going to read off of the x-axis. So I think mine would be about there. Again, be careful of the scale. Sometimes the scale on the x and the y-axis are different. In this case, it is the same. That's 3. So then I would probably read that as like 3.6. That's what mine would say. Yours might be different because you would draw obviously maybe a slightly different line of best fit. That's fine. I'm just going to have a look at the mark scheme just so I can say which, because they obviously give you a range. Okay, so they've said as long as you get between 2.5 kilos, obviously, months, and then 4.5 months. That's the range they've given. So it's quite a big range, really, if you think about it. Obviously, everyone's line of best fit will be different. So mine was roughly in the middle of that. So as long as you've got between 2.5 and 4.5, you should be absolutely fine. Okay, question 7, we've now got some percentages. The price of a holiday increases by 20%. This 20% increase adds £240 to the price of the holiday. Work out the price of the holiday before the increase. So this is actually what we call reverse percentages. We're working backwards. So I try and make an equivalence here. So that's this sentence. They've said the 20% increase, so 20% of what would have been the original price of the holiday, is equal to £240, isn't it? Literally, those two are equivalent. And then they've said, what was the price of the holiday before the increase? The price of the holiday before the increase was technically 100%, wasn't it? The original was always 100%. So do you see how I want to know how to go from 20% to 100? Now, there's different ways to do this, and depending if you have a calculator or not. Because we don't have a calculator, my thought process is, well, how do I go from 20 to 100? I obviously multiply by 5. That's what I would do in a non-calculator context. So I'm going to obviously therefore times the other side by 5, which you can obviously work out however you like. I would probably use, you can use column multiplication like this, or if you're happy, times in by 5 is the same as times in by 10 and then halving. That's a bit easier, really. But if you want to see column multiplication, multiply 0 by 5, obviously that's 0. 5 times 4 is 20, so that'd be a 0 and then a 2 here. 5 times 2 is 10, plus the 2 is 12. So 1,200. Okay, so the answer is 1,200. If I had a calculator, what I would have probably done is 240 divided by 20%, which is 0.2 in the calculator, isn't it? That would have given you the same answer, but obviously in this case, it doesn't really make sense to use decimals. Okay, question 8. The diagram shows a solid cylinder on a horizontal floor. So we've been given here, obviously, also the pressure formula. You don't need to memorize that, they will give that to you. The cylinder has a volume of 1,200 centimeters cubed and a height of 40 centimeters, which currently you can see is none of these measurements here, is it? So that's something to consider. The cylinder exerts a force of 90 newtons on the floor. So that is actually one of these things here. And they've asked us to work out the pressure of the floor due to the cylinder. So do you see how we currently, obviously, we want to work out the pressure. That's fine. And we've been given the force, 90. But the problem is, in the formula, they said area. And area is referring to this bit here, the bit that's touching the floor. Right? So it's not the whole cylinder, it's just that one face. So we, first of all, would need to use the information about the volume and the height to work backwards to find the area before we can actually work out the pressure. So we know that volume is effectively the area, like a surface area that's repeated, that's the circle, isn't it? Multiplied by either the length or the height. In this case, it's the height. So do you see how if I take that, let's rub out this and come back to that later. I know my volume is 1,200. I know that I don't have the area, but I know the height is 40, so that's 40 times by the area. Do you see how to find the area? I would just need to divide by 40. I'd need to reverse the volume formula. So what we want to do is 1,200 divided by 40. Now, again, you can use bus stop if you want. In this case, because I know that I'm kind of looking at a 12 and a 4, I'm probably just going to think of it as a fraction. And do you see how I could knock off zeros? And then I've got 120 divided by 4. That's quite easy, isn't it? You could just do 30. So you can use bus stop if you like, or you can just do it straight away like that as a fraction, up to you. So the area is actually 30 centimeters squared. Now I can go back to my pressure formula. So force, which is 90 newtons, divided by the area, which is 30 centimeters squared. And again, as a fraction, knock off the zeros. 9 divided by 3 is obviously just 3. So there's our answer, 3 newtons per centimetre squared. Okay, question 9, 1 mark. This is actually a really nice question, really easy question, but we just need to know how to do it basically. So use these graphs to solve the simultaneous equations. They've listed them here. You don't even need to read this, to be honest, as long as it's obviously the same as what's up here. They've drawn 2 lines on the graph. We want to solve the simultaneous equations because they're both linear, they're both straight lines. They obviously only cross at one point, hence why there's only one solution for x and y. So what we want is to go to where they intersect, where they are both, because you're basically looking for where x and y are the same for the 2 lines, aren't you? Well, that's obviously where they both like cross over. So I'm going to obviously, you can probably just read it off, but I'm going to use a line just so we can really see it. So on the x-axis, do you see how that is? Check the scale so that we're not wrong, but that looks like that should be 6. Let me check the scale. 1, 2, 3, 4, 5. Yes, the scale is 1 square is just 1, so that's fine. So x is 6, and then you see how y would be if I went across to the y-axis. I've not drawn that very straight, but you can see that that's obviously on the exact line from -2. Don't forget to put a negative if it is a negative. It's literally as straightforward as that, simultaneous equations on graphs. Sometimes you might have 2 points where they cross, in which case you have 2 answers for x and y. This one was just linear, so we only had 1 answer for x and 1 answer for y. That's all you need to do. That's why it's only 1 mark. That is literally all you need to do. Okay, question 10. So this is one where, again, you've probably forgotten what to do here because this is actually more of a Key Stage 3 one, but it is a really easy one to do if you remember the formula for it. So we've got a pentagon, obviously a 5-sided shape. They've told us that the angle AED, so that's the one up here, E, is equal to 4 times the angle ABC, which is the B one here. Work out the size of angle AED. So what I would probably do, I quite like to use algebra, that's just my preference, is the smaller angle, which is this one, always use x for the smallest one. If that one's x, do you see how angle AED would be 4x? The reason why I'm not using like x and y for 2 different angles is because I will only have enough information for one equation, so I want the same letter in this case. So that's x, that's 4x. Now, you probably don't know what all of the angles in a pentagon add up to. If you do, perfect, skip this next step. If you don't, because you don't technically need to memorize it, we need to use this formula. You might recognize it, hopefully do. n minus 2 times 180. That formula is one from Key Stage 3. It's basically to help you work out the total degrees in any polygons, any shape. So for example, a triangle we should know is 180. A quadrilateral, so a 4-sided shape, we should know is 360, but beyond that, we don't really memorize it, do we? So what we can use is this formula. So you don't have to memorize 10 different shapes, you can just use the formula and work it out. So for a pentagon, n is the number of sides, right? So 5 sides for a pentagon. 5 minus 2 times 180. And you just have to work that out. So obviously that's 3 times 180. You can either multiply it or you can just do 180 plus 180 plus 180. It's up to you, however you work that out. I'm probably going to use column multiplication myself. 3 times 0 is obviously 0. 3 times 8 is 24. So 4 and then 2 here. 3 times 1 is 3 plus 2 is 5. So we're saying that a pentagon adds up to 540 degrees. You might have known that, you might not. You can work it out using this formula. Do you see how then I could use that as an equation? As in, 540 degrees is equal to all of these angles added together. So that's why I wanted to write them down as x or 4x or something like that to find them. So we've got 120, let's just add the numbers, plus 135 plus 110 plus 4x plus x. And that's only one equation, which is why I needed only one letter, not 2 different letters. So now let's simplify that, collect the like terms. So 540 equals, you can obviously do column addition here, but that would add up to 365. So however you want to add that up, you can use column addition is probably the best way. Obviously x plus 4x is 5x. Then I'm going to move the 365 across because I want to solve this. I want to get x on its own, don't I? So if I subtract by 365, you can use column subtraction. I can show you over here if you want. Or you can obviously just add up the difference, up to you. 365, subtract. So just to go through column subtraction, if you've forgotten how to do it, 0 minus 5 would obviously be negative, so we'd have to borrow some. So I'm going to have to cancel the 4, make it a 3, borrow 1. So that becomes 10. 10 minus 5 is obviously 5. Fine. Then do you see how we now got 3 minus 6? So I'm going to have to borrow again. That can become 4. That can become 13 there. So that is 7. 13 minus 6 is 7. And then 4 minus 3 we can do as 1. Okay, so you can do it like that, or you can just go, well, what do I add to 365 to get to 540? That's probably normally what I would do. Luckily, it ends in 5, so we know it is a multiple of 5. Now we need to divide by 5, so you can use, obviously, bus stop if you like, however you want to divide. How many times does 5 go into 17? 3 times, with a remainder of 2. How many times does 5 go into 25? Obviously 5. 35. Don't know if we can see this. Might need to scroll it up a bit. Let's see if we scroll up a bit there. So can you see that? X is 35. Now the only thing that we've got now though is because you feel like, oh, I've solved it, that must be the answer. But actually, let's go back and remember what the original question was. Make my highlighter a bit smaller. The original question was to work out angle AED, which is this angle here. Do you see that? That is the 4x, isn't it? It's not just x. So my last thing to do would be say, right, I need to actually work out what is 4x. So 4 times 35. You can either, again, column multiplication or just keep doubling it. That's fine. So that would give us 140. So just double check. Is my answer the final answer? Do I need to go back and do something else? 140 is our answer. Okay, this one I think we should zoom in a little bit. Question 11. So we've got some indices now. Write 6x to the power of 5 y cubed, and then all of that squared, over 3x squared y to the power of 7 multiplied by 4x y to the power of minus 3 in the form ax to the power of b, y to the power of c, where a, b, and c are integers. So a, b, and c are whole numbers, that's what that means. This is just basically index laws, just a load of index laws all together. So I'm going to start with the top, with the numerator. That's, I feel like, probably the hardest bit. That's obviously our third index law. You know when you have to multiply the powers because there's brackets. So all of the powers within the brackets have to be multiplied by 2. Now, the tricky bit, I think, is the 6. A lot of people think, oh, it's multiplication, so I need to multiply 6 by 2. But that's not right, because 6 isn't it's not power, is it? It's not an indice. 6 is just a whole number. If I were to rewrite that, technically it's 6 to the power of 1, isn't it? X to the power of 5, y to the power of 3. So do you see how when I'm multiplying the powers, that would become 6, 1 times 2 is 2, so 6 squared. X, 5 times 2 is 10. Y, 3 times 2 is 6. And then because 6 squared is actually a number, I'm actually going to work that out. So obviously 6 squared is 36, isn't it? Y to the power of 6. So that would be the numerator. It's 36 x to the power of 10, y to the power of 6. Now let's bring that back. Now let's look at the denominator, actually. So the denominator, we've got multiplication actually written down, which means our first index law, which is to add the powers. But again, just look at these whole numbers. 3 and 4 are not powers, are they? They're just whole numbers. So in that case, those two, the 3 and the 4, you are just going to multiply as normal numbers. And then after the 3 and the 4, that's when we start using the index law to add. So 3 times 4 is obviously 12. And then you've got x squared times, now there's an x here, this is technically a power of 1, isn't it? It's not 0. It's technically a power of 1. So 2 plus 1 is 3, x cubed. Y to the power of 7 times y to the power of minus 3. So that's y. So that's 7 plus minus 3, which is obviously then, that does technically subtract, doesn't it? Y to the power of 4. So that's our denominator. So let's rewrite those together. 36x10 y to the power 6. And then 12, x to the power 3, y to the power 4. The last thing to do is then divide. It's an actual fraction is to divide, isn't it? Again, these numbers at the front, 36 and 12, are not powers. They're not indices. They're just numbers. So those you would actually just divide as normal, which obviously you can see they've chosen those numbers deliberately because they do divide to become 3. So we get 3 there. Then look at the next column, the x's. Because we've got x to the power 10 and then x to the power 3, when we divide them, that's the second index law, which is subtract the powers, isn't it? So that would be x to the power 7. And then same with the y's. They're both y to the power of something, so when I divide them, I can subtract the powers, which gives me y to the power 2, or y squared, in other words. So you've got 3x to the power 7 y squared. That's your answer. Okay, question 12, we have got obviously a probability tree here. They've already drawn it out for us though, so all we need to do is work out a certain probability. So we have Martha plays a game twice. The probability tree diagram shows the probabilities that Martha will win or lose each game. Find the probability that Martha will lose at least one game. So what I like to do is go through and highlight the options that satisfy the wording here. So she's going to lose at least once out of the 2 games. So again, let's zoom in a bit so we can see it properly. So I like to use highlighters. I don't know whether you do that in the exam particularly, but that's just how I like to demonstrate it for my students. So how could we show that she has lost at least one game? Well, the first obvious one is to lose the first game, isn't it? Let's try and highlight that nicely. Lose the first game. But then she could win the second game, couldn't she? Because she's lost one, she's won one. That's one option. Second option is that she wins the first game, but then she would have to lose the second one, wouldn't she? Because she does have to lose one of them. But there is also a third option. Because this wording, at least one game, means it could be one game that she loses. It could also be both games, because it's at least one game. So the other option is lose the first one and lose the second one. So I've got 3 out of 4 possibilities here that it satisfies my question. Now, you've got 2 options as to how you can work this out. You can obviously work out all 3 of these options, these 3 colours, and then add them together as normal. Or you could just work out the one option that's not highlighted. Do you see how that like win-win is the one that's not highlighted? You could just work out that one probability. Because all probabilities add up to 1, you could just subtract that from 1, and then the rest of it would be covering the whole of the other 3 options. You could do that. I don't really like to do that because I feel like I'll just end up getting confused. So I'm going to work through it just straightforward, all three probabilities separately. So for the blue, when we're working with probability trees, we always multiply between the branches because it's win and lose, or lose and win, or lose and lose. It's and, isn't it? Because they both have to happen because she does play both games. So win and win, win and lose, we've got 5/8 multiplied by 7/9. Now obviously multiplying fractions, just multiply straight across. So the numerator will be 35, denominator will be 72. Sometimes you can simplify these. I wouldn't normally, just because at the end it'll be easier if we leave them as they are. So don't simplify them even if you can. Then let's do lose-win, so the yellow one. So we've got 3/8 lose, 2/9 win, which is 6/72. And then finally the green one, lose-lose, we've got 3/8 lose and another 7/9 lose, which is 21/72. The reason why I've kept them as they are, I've not tried to simplify anything, is because you see how they all have the same denominator? And when you have multiple options, so in this case we've got 3 possible outcomes that could happen to Martha, it's either blue option, yellow option, or green, isn't it? This or this or this. One of those 3 options will happen. So that's the OR rule, which means add. So if I move it down, we're now going to add together those probabilities. 35 over 72 plus 6 over 72 plus 21 over 72. And when you're adding fractions, you obviously want the same denominator, which we've already got, so that's perfect. And then we just want to add the numerators, which we should get 62. Okay. Again, you could simplify that if you want to, but for probability, they don't normally really care if you simplify it, so I normally just leave it as it is. 62 over 72. And I wouldn't bother with a decimal either, just leave it as a fraction. Okay, question 13. We've got proportion here, so let's zoom into this one as well. Y is directly proportional to x. Y is 24 when x is 1.5. Work out the value of y when x is 5. So this is a perfect question. This is an ideal proportion question because we've just been given the 3 pieces of information that we need. Straightforward, nothing more complicated than that. So you first need to know the formula for proportion. And in this case, obviously direct proportion. The formula for direct proportion is y is equal to k multiplied by x. Now, if they use different letters, obviously change the y and the x, right? But in this case, they haven't, so that's good. It's k multiplied by x, which is effectively a straight line, isn't it? Like that. That's direct proportion. Then they will have to give you what I call a matching pair, so a pair of numbers for both y and x. The reason why we're given that is because we want to find out k. So that's step 1. Step 2, work out the value of k. So substitute in the 2 values that they've given you. So 24 is equal to k times 1.5. So I'll just write it as 1.5k. And then you see how I could solve this? I just need to divide by 1.5, which is mildly annoying, but that's fine. We can divide by 1.5. You could convert it into a fraction 3 over 2 if you want. You could divide it as it is. We could do what we did in the first question, where if you change both 24 and 1.5 by the same scale, you can divide that. So for example, you could change it to 240 divided by 15. See how I've multiplied them both by 10? You could do that. That might be easier to work out. And you could use, therefore, bus stop division. It's up to you. There's loads of ways to divide these things. So 15 obviously doesn't go into 2, so straight away to 24 it goes in once. And then there should be a leftover of 9. We remember, if you remember from earlier, 15 went into 90 6 times. So 16. And because I changed the scale both by 10, I don't need to adjust the answer. The answer is just 16. Okay, so however you would like to divide that, that's up to you. Once you've found k, I like to rewrite the equation with the actual value k. So that's y is equal to 16, oh, not 16k, 16x. So that's our relationship. We're saying that y is equal to 16 times x. Step 3 is then using the actual question. So work out the value of y when x is 5. So we just write down y, and then we sub in x is 5. That's as simple as it is, and then just multiply it. Multiplying by 5 is the same as if you want to multiply by 10 and then half it, so that would be 80. Okay, so see how we get these steps. Step 1 relates to the formula, step 2 relates to working out k, step 3 relates to working out the actual question. And normally proportion, it works the exact same way every time. So let's look at question 14. Hopefully you can see all of that. We've now got some indices again. So, question 14a. Write 1/16 in the form 4 to the power of n, where n is an integer. So n is a whole number, is what we're saying. So how could we rewrite 1/16 to be 4 to the power of something? The first thing I would think to do is look at the 16. So we've got 1 over 16 is the same as 4 squared, isn't it? So I can already write that as 1 over 4 squared. And then the only other thing I then need to do is convert the 1 over bit. What does that mean? How do I write that as a power? Well, hopefully you remember that a negative power is the reciprocal. And 1 over 16 is the reciprocal of 16, isn't it? So that means that it's the same as 4 to the power of -2, which is an integer. So not only do we need to be able to apply negative and fractional powers directly, but also reverse it. Do you see how we've undone that and figured out that it was a negative originally? We want to be able to do it in both directions, if that makes sense. Part B, now it's just fractional indices. So again, one of these where we can't really guess, you'd have to memorize what to do in this case. You'd have to know what to do with fractional powers. So fractional powers, first of all, look at the denominator. That means root. So in the case of the 8, do you see how it's a 3 is the denominator? That means cube root. And then the numerator is just a normal power. So I'm just going to apply that afterwards. You always do the denominator first as a root, then the numerator is just normal power. So same thing for the 9. Do you see how now it's a 2? So that's just normal square root. Obviously, they're not going to get you to square root or cube root a number that isn't already a square or a cube number, okay? They're not going to make you work out decimals like that. That would be really difficult. And then the 3 is just normal power 3. So cube root of 8, hopefully you know this, you should have this memorized, is 2. So then we'd work out 2 to the power 5, and then we'd subtract. Square root of 9 is obviously 3 cubed. And then you could work these out. 2 to the power 5 is just 2 times 2 times 2 times 2 times 2, right? 5 times. So that's 32. Minus 3 to the power 3 is 27. Okay, and then actually just, because they said work at the value, you've actually got to subtract that, so that's obviously 5. Okay, so they're just basically doing fractional powers twice. Okay, question 15. We've got some straight lines now, and perpendicular lines as well. So the equation of, the equation of line L1 is y equals 2x minus 5. So you can see that's in that format, y equals mx plus c, which is the format for a straight line. So that one's really nice, it's already in the correct format. Then we've got the equation of line 2, L2, is 6y plus kx minus 12 equals 0. That's still the equation of a straight line, but you see how it's just in a different format. We haven't got y as a subject there. Then they've told us that L1 is perpendicular to L2. That's the key piece of information there. Given that, we need to find the value of k. So, perpendicular lines, we should know it's all about the gradient. It means that the gradient is the negative reciprocal. So the gradient of line 1 would be the negative reciprocal of the gradient of line 2, for example. Now, we can only look at the gradient when it's in this format, where y is the subject, okay? Because m is the gradient, isn't it? It can't be when it's rearranged any different way. You have to have just a single y as a subject, everything else on the other side. So the first one, do you see how line 1, so m, which is the gradient for line 1, is 2, positive 2. It's in the correct format, I can just pick out that information. Therefore, these three little dots mean therefore, the gradient of line 2, if it is perpendicular like they've said, would be the negative reciprocal. So that would have to be negative, because you see how 2 is already positive, it would be negative, and then reciprocal of 2 is a half. Now, I can't just sub that in front of the x, because you see how that second line is not in the correct format. It's negative 1/2 when y is in this format, where y is the subject, right? Where it's not 6y's. Everything on the other side, y on its own. So at the same time, I'm also going to rearrange this first one here. 6y plus kx minus 12 equals 0. I'm going to move both the kx and the 12 to the other side to leave y on its own. So do you see how that would be minus kx plus 12? Just trying to write it in the same format as the y equals mx plus c. And then you'd have to divide by 6. You see how you'd get minus k over 6 x plus 12 over 6, obviously 2, that's fine. I'll make that look more like a 6. No, let's redo that. So, I know that what should be in front of the x is the gradient, isn't it? And I know that the gradient should be negative 1/2. That's what we've just worked out, isn't it? So do you see how I can then write that as an equation, just ignore everything else, and put, I know that the negative 1/2 should equal to negative k over 6. And now I can just rearrange this to find k. So first of all, you see how they're both negative? Well, you can cancel out the negatives or divide or multiply by negative, it would cancel them out, wouldn't it? So we've got a half is equal to k over 6. I'm going to cross multiply. Let me rewrite that so we can see it properly, shall we? Cross multiply, what I mean by that is just multiply by the denominators to get rid of the fractions. So I'm going to multiply 2 and 6. So 6 would be on this side and 2k. And then, obviously you can see you can just divide by 2. So k should be 3. I think the k bit's a bit complicated there, but the first bit in terms of working out the negative reciprocal and then also rearranging, you can definitely do that bit. Hopefully that k bit at the end makes sense. Question 16. So we've now got a sphere. They've given us the equation of the surface area of the sphere, which is 4 pi r squared. You don't need to memorize that, they will give you that. Anything like a cone, sphere, hemisphere, they'll give you the formulas because they're not prisms, okay? They've then said that 3/8 of the surface area of the sphere is 75 pi centimeters squared. So 3/8, not the whole thing, just 3/8. With that information, we need to find the diameter of the sphere. So I need to set up an equation to see how whenever you say this is something, is the same as equal, isn't it? It's an equation. So 3/8 of the surface area, and the surface area is 4 pi r squared. So do you see how I could write that as 3/8 multiplied by 4 pi r squared is equal, just put equal wherever you see the word is in the sentence, 75 pi. And then because I've got this equation, do you see how the only letter I don't know is r, which is the radius? Well, that's helpful, isn't it? Because we can use the radius to find the diameter. So I'm just going to literally solve this equation to find r. So however you want to apply this fraction, you could either divide it across or you could expand it out. I mean, that's up to you. I think I'd probably expand it out. So we need to know how to multiply a fraction by a whole number, because 4 is just a whole number, isn't it? Technically, any whole number is over 1. And then if you multiply that, obviously numerators would be 12, and then denominator would be 8. Okay, so just be careful that you do know how to multiply not just fractions with each other, but fractions with a whole number. And then obviously the pi r squared would still be there. Okay. I could then simplify that fraction, couldn't I? That would just become 3/2. So I'm just going to rub that out to save some space. That would become 3/2, wouldn't it? The other thing, do you see how they both got a pi? Well, if I divide across by pi, they cancel, don't they? That's easy. So we've got 3/2, or in other words, 1.5. R squared is equal to 75. I need to divide across technically by 3/2. It's non-calculator, so probably what I would do is times by the denominator. So multiply by 2, which is 150, and then divide by 3. You could do it in 2 pieces if you prefer. So that would be r squared is equal to 50. Now, we're obviously going to now square root. Do you see how before I said they won't make you square root something that's not a square number? 50 is not a square number. That's why, if you look back at the start of the question, it says give your answer in the form a root b, so square root, we've got some surds. So that's fine. You don't need to actually literally square root 50. You just need to write it as a square root 50, if that makes sense. Now, that's the radius. Again, don't forget that you think, oh, I've solved it, that's the answer. No, they asked for the diameter. The diameter is 2 times the radius, isn't it? So I just need to do 2 root 50, 2 lots of root 50. Now, the last thing though is double check. Let's see what they said. Give your answer not only in the form a root b, which we've got, but they said specifically that a is an integer, so whole number, that's fine, and b is a prime number. As you can see, 50 is not a prime number yet, is it? 50 is not a prime number. So that's just telling me that I need to simplify my surd further. So this is now just surds, isn't it? So leave the 2 out the front. How can I simplify my surd? Is there a square number that goes into 50? Well, yeah, 25 goes in, doesn't it? And then you'd multiply it by 2. Then you square root the 25. Can we still see that? Let me move over here. You would square root the 25. So see how I've got the 2 at the front. The square root of 25 is just 5. That becomes 5. And then root 2. I'd have to multiply 2 by 5, which is 10. Now 2 is a prime number, isn't it? And 10 is obviously an integer, so that would be my answer, 10 root 2. Okay, so just double check, have I actually answered the question in the format they've asked for as well? 10 root 2. Okay, question 17. Make x the subject of the formula, and can you see how in this one we've got x in 2 places? That's why this is a question 17 and not a question 5. So what we need to do here, get a bit closer again. Oh, too much. There's a very specific way to work these out, which is good because it means if you've learned the specific way, you can just apply it every time. If you see that you've got the letter that you want as the subject twice in the equation, then we want to, first of all, get rid of the fraction because that's kind of locking everything together, isn't it? So I'm going to multiply across by the denominator first of all, which you might think seems counterintuitive because we're going to be mixing up x and y's, but I promise it is fine. So first of all, I'll write it as brackets and then we'll expand it. So get rid of the fraction because that's just blocking everything, isn't it? Then I want to get rid of the brackets because again, it's blocking things inside the bracket. So expand both sides. So we get 5xy plus 3y. And then on the right, we get 8x minus 28. Then what you want to do is, because we want x, get all of the x terms together on one side and anything that's not got an x in it on the other side. So there's 2 ways you could do this. You could either move it obviously left or both of them to the left, both of them to the right. It's not right or wrong. I personally choose the side where I'll get the least negatives. So probably I think what I might do is actually move in terms of everything, all the x's to the right, because I think overall I'll have fewer negatives and that's just what I prefer. So 3y, I'd have to add 28, wouldn't I? So that would become positive here. 8x is already fine. And then I'd only just have to subtract the 5xy. Do you see how that's the only one with a negative? So that's a little bit easier than moving all of them to the left, which you can still do. It's absolutely fine. It's not wrong. But I just prefer it this way. Now, this is the key thing. Now, do you see how we've got the x terms together? But we can't actually subtract them because one's an x term, one's an xy term. They're not like terms. So the way that we combine the x's is by factorizing. This is a bit you need to remember for this topic. Just pull out the x. And then obviously the other side is still the same, 3y plus 28. And then the last step is to get x on its own. I just need to divide by the whole of this bracket to move it across. So we get 3y plus 28 over 8 minus 5y, which equals x. So this is the key bit here. That's the bit, how you get the x's together, factorize it. So that would be your answer. As I said, you might have moved them all to the left, in which case I'll write down the answer that you could have also got if you did it that way. It's also correct. The other option is x is equal to minus 3y minus 28. It's basically all the symbols are just swapped. Do you see how compared to my answer, they're all just the opposite? I just didn't do it that way because I just don't like the fact there's 3 negatives, but it is still technically correct. So you could get either or. There we go. One of those 2 answers is absolutely fine. Let's move on to question 18. Okay, this is an interesting one. So we've got 7 kilos of carrots and 5 kilos of tomatoes cost a total of 480. Hopefully you could already look at that and go, I could make an equation out of that. But the other thing then, you're thinking, well, I've got carrots and tomatoes. That's 2 different things. You can also see in the answer. 2 answers. So I'm thinking initially, when I look at this, an equation. First of all, that first sentence, very clearly, I can create an equation. But the other thing is that it's got 2 different letters, C and T, for example. So therefore, if you've got 2 unknowns, 2 different letters, you need 2 equations. Or if you've got 3, you need 3 equations, and so on. So that's why we've then got this second bit here. They've then said that the cost of 1 kilo of carrots to the cost of 1 kilo of tomatoes is the same as 5 to 9 as a ratio. That's where we'd have to try and derive a second equation. That's the bit that's why this is question 18 and not like at the start of the paper. Work out the cost of 1 kilo of carrots and 1 kilo of tomatoes. It's basically saying solve the equations, isn't it? So hopefully you could see that underneath this, it's simultaneous equations. So the first equation, really straightforward. I would just literally write it as 7c plus 5t. You can use x and y if you want, but I'm just going to stick with the letters they've given me so I don't get confused. Is equal to 480. That's fairly straightforward, isn't it? The second bit is a bit about ratio that is why this is towards the end of the paper. There's two different ways to convert this into a fraction equation, either with fractions or not. So that one's c, and then this side is t, isn't it? I'll write down both ways. You can use either. Either you write it as fractions. You put the c over the t equals, and then you put the same numbers in the same place, so like 5 over 9. And then that's an equation. And you'd obviously just have to rearrange it. That's one way to convert ratios into equations. Okay, the other way is that you write it without fractions, but you have to swap the numbers. So you put 9c is equal to 5t. Just remember, as long as you remember to swap them around. So that, again, that's an either or option. I went with this one because I feel like that's just, at least there's no fractions, right? You could use the other one and you just have to rearrange it to try and make it look a little bit nicer and not have fractions. So I'm going to use this one, 9c equals 5t. So you see how I've got my simultaneous equations here, equation 1, equation 2. What I'm going to do is, you can either, because this is linear, isn't it? It's just c and t, it's not squared, it's linear. You either use the elimination method or the substitution method. So I think this one, well, at least with the way I've done it, lends itself quite nicely to substitution, because it's saying 5t is the same as 9c, so I could literally just replace 5t with the 9c, couldn't I? Or you can use elimination, that's also fine, whichever you prefer. So I'm going to substitute it in. So instead, we've got 7c plus 9c is 480, and now I've got an equation with just c, just one letter, so now I can actually solve it. So add those together, that's obviously 16, oh, that's a horrible 6, let me redo that. 16c is 480. I said before about learning the 15 times tables. I think it's also probably helpful to learn the 16, again up to like 5 times 16, because that does tend to come up quite a lot. So c divided by, I need to divide it by 16, don't I, to get c on its own. So I would probably just do 48 divided by 16, because I know that's 3, and then add the 0 again, 30. So the cost of carrots for 1 kilo is 30p. Once you found out one, it's quite easy to find the other, isn't it? Just sub it back in to one of the original equations. So I'm going to sub it into the second one. You can do it to whichever. I think the second one's easier. 9 times 30 is equal to 5c. Oh, sorry, 5t. So that's 270, isn't it? And then divide by 5. Dividing by 5. We've already talked about timesing by 5, haven't we? Dividing by 5 is like dividing by 10 and then doubling it. So divide by 10 is 27. Double it is 54. Just in case you didn't want to use bus stop. And there's t, 54. And they've only asked for 1 kilo of each, so that's why I've not done anything else. So this is linear simultaneous equations, which is technically a grade 4 or grade 5 topic. However, they put it into a context where it is much harder. That's why it's question 18. Okay, question 19. Question 19, this might be a topic that you might have seen a while ago. Hopefully you've not forgotten about it, but I think this is one where a lot of people forget that it exists, really. So, the menu in a restaurant has starters, main courses, and desserts. There are 5 starters, there are 12 main courses, and there are X desserts. They then tell us that there are 420 different ways to choose 1 starter, 1 main course, and 1 dessert. Work out the value of X. So the topic here is called product rule for counting. Let me just write that down just in case you want to look it up. I've got a video on it as well, which I'll link down below. So you can see more of the questions. Rule for counting. Product rule, because product means multiply, doesn't it? And then counting is obviously we're saying how many possible combinations. So a lot of the time it's starters, main course, desserts. It could be different teams, like how many times could they play with different teams. Different outfits, you know, like they've got this many trousers, this many tops, this many shoes. You know, it could be anything like that, but they're basically combining things into different combinations. So product rule means multiply. So if you were to work out how many different, let's say we didn't know what 420 was, the way we would work it out is you just multiply all of those together. So for example, I've got 5 starters to choose from. Then I can choose 12 main courses, like 1 of 12. And then I can choose, in this case, X desserts. The reason why I can do it like this is because if I choose one particular starter, it doesn't affect how many main courses I can choose, does it? They're all separate categories. So I just multiply all of them together. That is what would equal to your 420. So again, we're just creating equations. So on the left-hand side, I'm going to actually multiply 5 times 12, which is 60, and then x, 60x. Do you see how I could really easily solve that? That's why it's only 2 marks. Divide by 60. Again, if you want to put it as a fraction, you might be able to see the answer already, but put it as a fraction, knock off the zeros. 42 divided by 6 is 7, isn't it? So it's product rule for counting, but this one was like working backwards. Okay, we're getting closer to the end now. Question 20, we've got functions. So part A, we've got find g to the power of -1x, which is the inverse function basically, isn't it? We need to know that that format is referring to the inverse function. Let's have a look. So this one we only need to focus on g, we don't need to worry about f, okay? Just leave that for now. The way that we work out the inverse function, the way that I do it is I change the g of x for y, just to make it simpler, that's the only reason. Root x plus 2 over 5. Then what I do is I change the subject. So I want to make x the subject. So I would multiply by 5. Oh, sorry about the noise. I would multiply by 5. Do you see how then I would subtract 2? Let's actually do it all in. There's not a lot of spaces there, but you could do it all in one step if you could visualize it, but I'm just going to try and show you everything. See how then I would subtract 2 because it's on the outside of that square root, isn't it? It's not involved in the square root. And then see how the last thing I would do to get x is to square it. The opposite of square root is to square it. Just put it up here. So I would just write it as brackets. I wouldn't literally expand it all out. Just leave it in brackets squared x. And then I would swap, obviously, because we don't actually want y, do we? I'd swap it back. So as in, I'd put the x back here where the y is. And instead of y, I would put, obviously, this is now the inverse function, isn't it? So the answer is 5x minus 2 all squared. Try and write that better. 5x minus 2 all squared. That's my answer. Some people like to swap it at the beginning and then make x the subject at the end. Also fine. Doesn't matter. Whichever you prefer. Okay, part B. So we do still need to see the 2 original functions here. Solve g of f of x is equal to 3. So this is a composite function, isn't it? And with composite functions, we need to know, we're subbing one into the other, but particularly we need to know which way round. It's always, I think of it as backwards, so like this way. As in, I'm going to take the whole of f and I'm going to sub it into wherever there's an x in the g function. So I'm going to do that first. We'll worry about the 3 in a minute. So instead of root x, it's going to be root 3x plus 4. So you see how that's the whole of f, isn't it? Plus, and then the rest of the g one, which is plus 2 over 5. Okay, we're not using our answer obviously from the previous one because that was inverse, right? Use the original. Now, all of that they've said is equal to 3. Okay, so you see how, again, we're just back to equations again. So I just need to solve this now because they've said solve it, find x. So first of all, I'm going to multiply by 5, get rid of the fraction. So we have root 3x plus 4. Let's try and keep that all in the square root. Plus 2 is on the outside, and then that equals 15. Then I would obviously subtract 2. Root 3x plus 4 is equal to 13. Then we need to square it to open up that square root. So squaring both sides, we get 3x plus 4, and then 13 squared, hopefully you know, is 169. And then from here it's pretty straightforward, isn't it? Take away 4, 165, divide by 3. Again, you can use bus stop if you prefer, or if you can figure it out just as it is, that's great. Into that would be 5 with root remainder 1, and then that would be 5 again, 55. This one they have just asked for 5 for x, so that is just 55. Okay, so that's your functions questions. Question 21, we've now got circle theorems. So let's have a closer look again. So A, B, and D are points on a circle with center O. CDE is tangent to the circle at D. You can see it's crossing there. Work out the sides of angle ADC. So A to D to C. Oh, okay, so this one on the outside. Let's highlight that. Write down any circle theorems you use. Okay, so you'll get another mark, possibly 2, probably only 1 mark for that, but writing down the names of the circle theorems you've used is important. Normally with circle theorems, there's a couple of different ways you could do it, so I'm just going to show you the way that I figured it out, but there are multiple different ways, and as long as you do get the same answer at the end, then it would be fine. So the first thing that I saw was, actually it was quite hard to identify this, but I mean, once you've seen it once, hopefully you'll pick it up again. Let me see if I can try and draw the original circle theorem for you. Can I get a circle? Yeah. Oh, that's huge. I'm just gonna roughly show you this. It's the one that looks a bit like an arrow, like that, and then it goes to the center. You most likely have seen that. I feel like this would be more familiar. This is the center here. It has to be. It's the one where they say the angle at the center is double the angle at the circumference. That is the one that we can use here. But imagine if I just picked up, like if you were to pick up this corner and drag it like down here somewhere. That, get a different color here. If I were to drag that, do you see how I could end up with like something like this? Oh, I don't know if you can see that, but that's the same that we've got here. If I were to pick up corner A, and if I were to drag it all the way up here, it would give me this arrow shape. That was really bad drawing, but it would give me that arrow shape, wouldn't it? So it's still the same angle at the center is double the angle at the circumference. It's just that I've taken that arrowhead and kind of dragged it all the way to one side so it overlaps rather than looking like an arrow. So what we're saying here is that this angle is half the center one, and half of that is 32, isn't it? So you could write down here angle, what is it, BAD is equal to 32, and they said write down any circle theorems you use, so you would say the one literally angle at, you don't have to write a full sentence really, just as long as you've got the keywords. Center is double angle at circumference, something like that. Okay, that's the first one. From here, I feel like it was kind of tricky to figure it out, but I think from there, it doesn't always have to be circle theorems. It can be any angle facts that you know. So what I used personally was I used the fact that the triangle here, I have 2 of the angles already, so I could work out this third angle here. See that? So I just did 180 minus both of those, 32 plus 51, which gave me 97. So that one there is 97, it's kind of too small to write it, but that one's 97, let's write that better. And because those 2 lines cross, do you see how like the other side of that would also be 97? So that's how I kind of used that information to jump into the other triangle. I'm now trying to get closer to my pink angle. So this one you would just write, you have to write down which one you use. Oh, write down any circle theorems you used. Well, it's technically not a circle theorem actually, is it? So let's check the mark scheme if we even need to write the triangle one. If it says write down any reasons for your working, then you do need to write down angles in a triangle, add up to 180 and all, like anything that you've used as a reason. But let me see. Oh yeah, I think in this case, because they said angles, any circle theorems, you probably don't even need to write about the triangle, but I mean, it's up to you. You can write it anyway if you like. So then that one over there is also 97, which is not a circle theorem. I've just used that, just an angle fact there. So we don't really need to write that one down. And then I did the same logic again where I said, well, that's now a triangle, isn't it? The OD and then this one here. So I did 180 again. 97 plus 64. And that gave me 19. So that would be this angle here. Now we're going back to circle theorems. The circle theorem I'm going to use is, see how OD is obviously a radius, isn't it? And then we have a tangent. We haven't used the tangent yet. The angle between a tangent and a radius is always 90. It's always perpendicular. So do you see how therefore I could work out 90 minus 19 would be my answer, which is 71. And I'd write down angle between, don't know if you can see this, hopefully. Tangent, let's move this up a bit more. And radius is 90. Now that's one way of doing it, so the answer is 71. That's one way of doing it, right? There are other ways to do it. I think you could also use alternate segment theorem if you were to draw other lines in. With any angles questions or particularly circle theorems, you can also draw your own lines in to create circle theorems as well. That's fine. So you could also use, I think you could have somehow used a cyclic quadrilateral. You could have also used alternate segment theorem. There's different ways to do it, right? But just whichever you can kind of pick up on first is fine. Okay, question 22. This one I can already see before I've even really read it. We've got a 3D shape. We've been given some side lengths. They've asked for an angle, and it's question 22. So I'm thinking this is most likely going to be 3D trig. So let's have a look. So we've got here a cuboid, not a cube, it's a cuboid. Okay, so not all of the sides are the same. They've told us that AF is 6.8, so let's just draw that on if they haven't already labeled it for you. And they've said that FC, where's that? Oh, it's a diagonal line through it, it's 13.6, so let's draw that. Always draw on for 3D trig ones if they haven't, oh, I don't want it pink. If they haven't already drawn it for you, you can obviously always draw on your own lines. So I'm going to draw F to C, just because they've literally given me that one, haven't they? That one is 13.6. And then they've said work out the size of the angle between FC and the plane ABCD. Now this one is, I feel like it's quite a common question, especially for Edexcel. It's quite a common question to ask between an angle between a line and a plane. Because I think you don't always know what they mean by that. Obviously the line is fine, but it's like, are they talking about this angle? Are they talking about like the angle to AD? Like what do they mean by the plane? So the thing to remember about 3D trig is the context is 3D. So in this case we've got a cuboid, but the trigonometry, or sometimes there's Pythagoras as well, the trigonometry is always still two-dimensional, which means it's still going to be a 2D right angle triangle. It might just be that the triangle lies flat on the base. It might be that the triangle is stood up going through the cuboid. It won't ever be like a diagonal triangle. It'll either be a horizontal one or a vertical one. So if you ever see this where it says the angle between some side, which you can draw on if you need to, and then a plane, draw a diagonal line through that plane. Now, in this context, it makes sense to go from A to C, doesn't it? Because we've got the line FC. Like, I know that there's a diagonal here, but that doesn't help us connect to FC, does it? So I'm not going to draw that one. Draw a line diagonally through the plane that they've referenced. And then do you see how not only does that create a 3D, not only does that create a triangle, right angle triangle, AFC, but the angle is then this. It's just an upright, like a triangle that stood upright through a 3D shape. So now that we've got this, just try and focus in on that triangle. How do I work out the angle? And this one was actually 2 marks. I don't know if you saw that. It was only 2 marks, so it's not really a huge question. It's just trig straight away, isn't it? So AF is the opposite, FC is the hypotenuse, So you go SOHCAHTOA, well, it's obviously sin, isn't it? And then, because we're looking for an angle, it's opposite over hypotenuse. I normally use the triangle like this, but obviously for an angle, it's just O over H. So sin of the angle, let's just call the angle X for now. Sin of the angle X, hopefully that's not too far down, I'll scroll down in a minute, is the opposite, 6.8, over 13.6, which you're probably looking at going, this is mental, this is a non-calculator paper, what do you mean? But they've chosen numbers deliberately, okay? They won't choose numbers that are too difficult. And obviously you're supposed to have memorized certain values for sin, cos, and tan. That's obviously will come out here. So we need to divide 6.8 by 13.6. Some of you might have already seen what it is, but if not, we can use our same trick where let's just make them both bigger. So I'm going to multiply them both by 10. 68, 136. You can either leave it as a fraction, or you can obviously do bus stop. I'm probably going to do a fraction in this case. So let's see, they technically both divide by 4. Not sure if they might both divide by, I think they both divide by 8, but I feel like naturally you'd probably just go with 2, wouldn't you? So I'm just going to follow that. See how I then get, nope, not 32, 34 over 68, and I don't know if that's a clue. And then I could divide them by 2 again, couldn't I? 17 over 34, I don't know if you can see the pattern here. Then they both divide by 17. See how that's a half? You might have already noticed it initially. They won't choose numbers that are too difficult, I promise. So sin x is equal to half. Now, what obviously you would do if you had a calculator, you'd do sin inverse, half. We don't have that. So you just have to memorize which value in terms of angles, so it's 0, 30, 45, 60, 90, is equal to a half for sin. Well, hopefully you remember that that is 30. The other thing is that in the context of a triangle, this one's already 90, isn't it? So the other one can't be 90 because there's 2 other angles, right? They'd have to add up to 180. So it's either going to be 30, 45, or 60. So worst case scenario, if you've forgotten, just guess one of those. Okay, so that is our answer. If I zoom out again, I don't know if you can see that. That was 2 marks. It wasn't that many marks because it was literally, I mean, the actual trig itself was like only 1 step. Okay, 23, we've got surds now. So write 3 root 3 over 4 minus root 3, subtract 2 over root 3 in the form a root 3 plus b over c, where a, b, and c are integers, again, whole numbers. So here we've got subtracting fractions. I don't think I'd worry about that yet though. What I would think to do with surds when you've got fractions is rationalise them first. That's kind of my first thought, rather than the fractions themselves. So rationalising the denominators, we've got 2 separate fractions with 2 different types of denominators, one that has 2 terms, one that's just 1 term, so that's slightly different, isn't it? So let's just take the first fraction and deal with that first. When we want to rationalise a denominator, first of all, what does that mean? That means get rid of the surd in the denominator. I can still have a fraction, but it has to have a whole number in the denominator. It's because a surd, so for example, root 3, if you put that in your calculator, it would give you a certain number of decimals, but technically the decimals go on forever because there is not really an actual square of 3, is there? Square root of 3. Because 3 is not a square number. So technically the decimals are infinite. How can you divide something by something that is an unending number? Do you see what I mean? Like, it's kind of impossible to do that. So that's why we're saying it's not rational. Doesn't make sense. Okay, so we need to rationalize it by creating a whole number in the denominator, because then a whole number is finite, isn't it? It does end. It does have an ending, so you can divide by it. So the way that we just need to memorize this, when you've got 2 terms, you see how I've got 4 and a root 3, they're separated by either a plus or a minus. We are going to multiply by the same thing. However, we have to change the symbol. So that's currently a negative. I'm going to therefore multiply by 4 plus root 3. And then just with fractions in general, whatever you do to the top, you have to do the same to the bottom and vice versa. So do you see how we're ending up with some double brackets? Well, the numerator would be single brackets, wouldn't it, here? If I multiply it, and then we'd end up with double brackets in the denominator. But yeah, you just have to remember, change the symbol if you've got 2 terms in your denominator. So if we were to expand that, 3 root 3 times 4 is just 12 root 3, because you see how the 4 is not a surd, it's just a whole number, so that would just be on the outside, plus 3 root 3 times root 3. That would technically be 3 root 9, wouldn't it, because the two surds multiply together. But obviously 9 is a square number, isn't it? So that could just square root to be 3, and 3 times 3 is 9. So I'm just going to write 9 here. The denominator is, I don't know if you remember this from algebra, is effectively difference of two squares, because do you see how we've got exactly the same bracket except one's plus, one's minus? So when I expand that, if I show you, we'd get obviously 4 times 4 is 16, which is fine. We'd then get 4 times root 3, so that's plus 4 root 3. Then we'd get minus 4 root 3. So you can see why that plus and minus is important there. And finally, be careful with this one, root 3 times root 3, obviously as we've just seen in the numerator, cancels out to become 3. But do you see how one was a negative, one was a positive? So that's actually minus 3. So just be careful you got that symbol right there. And do you see how then those middle two, I know we still have surds in the denominator, but technically they cancel, don't they? Because one's a plus, one's a minus, and it's the same quantity. So that's how we cancel out the surds. We have to have 1 plus, 1 minus. So if I rewrite that, this is, again, we're just focusing on that first fraction right now. 12 root 3 plus 9 over 16 minus 3, which is 13, which is a shame because that doesn't, I was hoping that would simplify, but it doesn't. That's now rational. It's okay if you have a surd in the numerator, as long as you're just not dividing by 1. So that's that first fraction changed, rationalized. The second one's much easier because it's only got one term, isn't it? You see, it's just a root 3. So in that case, we don't need to change any pluses or minuses because there are none. You just multiply the top and the bottom by that same surd. So you'd get 2 root 3 over root 3 times root 3, we've just literally just said, is cancels out to become 3. So what I would do now that I've rationalized both is go back to subtracting them. So let's rewrite that. We've got 12 root 3 plus 9 over 13 minus 2 root 3 over 3. And we obviously still need to have a common denominator, but at least now the denominators are both just numbers. There's no surds, there's no two different terms. It's not as complicated. So common denominator, kind of annoying. The common denominator, lowest common multiple, is 39. So I need to multiply the first one by 3. So 12 times 3, it's only going to affect the whole numbers, not surds. So we've got 36 root 3 plus 27 over 39 minus, the second one I need to times by 13, so that would be 26 root 3 over 39. And now do you see how I can subtract the numerators? Because they're both in terms of root 3, as in the 36 and the 26 root 3s, those I can subtract. You can only subtract surds if they have the same surd. So 36 minus 26 is 10 root 3, and then the 27 at the end is still just there. And then obviously over 39. Now I would check to see if I can simplify anything, not the root 3, but the 10, 27, and 39. Do they have a common factor between the three of them? Well, actually they don't, do they? So I can't actually simplify that. That is just my final answer. And if we come back, let's just check that that is, you can see that's the format they've got, isn't it? Something root 3 plus something else over something else. And they're all obviously integers. So that's fine. Okay, we're on a final question. We've now got inequalities, but as you can see, quadratic inequalities. So find the set of possible values of x for which we have 4x squared minus 25 is less than 0 and 12 minus 5x minus 3x squared is greater than 0. So we've basically just got two separate quadratic inequalities. So I'm literally going to solve them both separately and then we'll bring them back together at the end. So the first one, hopefully you can recognise that is difference of two squares. If I were to solve it, obviously normally with quadratics and particularly with inequalities, quadratic inequalities, we want to factorise. If you were doing the calculator questions, the calculator papers, you could obviously put it in to your quadratic formula. I mean, you still can if you want to work it out that way, just manually yourself. You can solve it that way. You could complete the square if you wanted, but I just feel like the most straightforward way to do it is to factorize. So this one is difference of two squares. This will come up definitely at some point in one of the papers. I promise you this will come up. So they put it in the inequalities this time. I've seen it a lot in algebraic fractions. It could be in a lot of different ones, but just make sure you can recognize difference of two squares. What I mean by difference of two squares is, see how 4 is a square number, x is a square number? X squared is a square number, so those two together are square numbers. Minus, which is difference, and then 25 is also a square number. That is difference of two squares, isn't it? But now I'm just going to put equals 0, and then we'll come back to it. So to factorize it, you get 2x minus 5 and 2x plus 5. So basically it's exactly the same brackets, except one's plus 1 minus, which is effectively what we did in the previous one with the surds, isn't it? And you just square root. So the square root of 4x squared is obviously 2x and 2x, and then the square root of 25 is 5 and 5. So solve these. We obviously get x is equal to 5 over 2 for the first one, or then just the same but the negative version for the second one. Which I think I might move this over a bit. That there. And then, so I've solved it, but I've not solved the inequality, have I? I need to put the inequality symbol back in. Now this is one where I would just probably recommend memorizing it. There's only two possible answers, as in formats. And it depends on which way the symbol originally faced. Did it face towards the quadratic? Did it face towards the 0? In this case, it faces towards the 0, less than 0. So if you get it where it's less than 0, that means it's a range, as in x is between these two numbers. Now obviously put the smallest number on the left. So negative 5 over 2, x, and then positive 5 over 2. Just so you know, if it faces the other way, so like let's say it faced this way, it faced towards the quadratic, it would be two separate inequalities, where it's x is less than the smallest number and x is greater than the biggest number. But for this one, it's not that. So that's the first one solved. Let's do the same with the second one. The second one's kind of interesting because we've got a negative quadratic. Do you see how it's negative 3x squared? I personally would rather not factorize a negative quadratic. So what you can do is move things around. I'm going to move all three terms to the other side, just so that because if I move negative 3x squared, I would add it. It would become positive, wouldn't it? So we'd end up with 0. The symbol would still be in the same place, same direction, because I'm just adding and subtracting. Add 3x squared, add 5x, and then minus 12. That's what I would do, just to make it easier, because now if I try and factorize that, it's a little bit more straightforward. And I'm going to just put equals for now. Factorize 3x and x, because that doesn't split any other way. We've got a negative 12. We're multiplying to make negative 12, so one's a plus, one's a minus. And we need factors of 12 that would add up to 5. Obviously, one of them is times by 3. So however you want to factorize, these are called like harder quadratics, aren't they? However you would go ahead and factorize it, do that. But we should get minus 4 plus 3. And then you solve it in the same way. So we get 4/3 or negative 3. And again, now I need to put it back into my inequality. It's facing the 0. So then that's the same thing. It's another range. So the smallest number is minus 3. X, and the biggest number is 4/3. So that's the two solved separately. The final thing we need to do is literally just see where they overlap. So a set of possible values, so a set is, again, using inequalities for x for both of them. You might be able to just look at it and figure it out. If not, you can always obviously draw a number line. So 5 over 2 is negative 2.5, isn't it? So negative 3 is smaller. Then we've got negative 5 over 2, or 2.5 if you prefer. 4/3 is like 1.3 recurring, and then that's 2.5. So 4/3 is here. Obviously, just make sure you put the numbers in the right order. Oh, complete wrong way around. 5 over 2 positive. So if we do them separately, this one is like, if I were to draw it, it would be like this, wouldn't it? And then if I do the other one in green, that one would be like this. So do you see how if I just look where they overlap, is negative, scroll up a bit, negative 5 over 2 and 4/3. And it's again a range. It's between, x is between those two values, isn't it? So my final answer would be -5/2 is less than x, which is less than 4/3. That's the bit that covers both of them, doesn't it? Where they both overlap. And that was 5 marks. That would be your answer. So as you can see, total for the paper is 80 marks. That's the end of the questions. If you need any of the formulas, I think the formula sheet is here at the end. You can always obviously refer to the formula sheet for any of those questions. Otherwise, that is everything on the June 2023 paper 1H, the higher tier paper. If you have any questions, obviously, please leave a comment down below. You can also look up the mark scheme. I will try and link everything as well. If you want to go through any of the topics that have come up on this paper, I've got quite a lot of those as videos already, which again, I will put into I think I've already put it into the description. But otherwise, if not, check out my channel. You can find a lot of those topics already as full videos. If you want to go through more questions, then that is fine. Otherwise, thanks for watching, guys, and I'm just going to end